It's 10:50, friends, so I think that I'm good to get going. Thank you for joining, and I specifically want to give a shout out to Anthony, Mark, and Andrew for the chance to speak today. I really appreciate it. It's always an honor to be selected, and it's not anything I ever take for granted. So thank you, and thanks to Ree as well. Ree is moderating for me today. So we're going to talk about statistics in SQL Server, and just a couple things as we get rolling here. This is my yay me slide, and the most important thing on this slide is my email address, erin@sqlskills.com. You have a Q&A, question and answer panel where you can ask questions, but if you don't get them answered today or you think of something later on, feel free to send me an email. I'm a consultant for SQL Skills. I list the team members up here because sometimes I refer to one of them during a session. So Kimberly and Paul are the owners, Jonathan, Tim, and myself are consultants, and we provide services and training. And if you want to learn more about the things that we offer, please visit our website. Just a couple reminders. I feel like we've said this a few times, but just so that you don't have to ask again. The scripts for this session along with the PDF are going to be on the GitHub site for 8KB. And this session is being recorded, will be recorded, will also be available on the 8KB YouTube channel. And again, please put your questions in the Q&A. Chat is not being monitored. Chat's great for talking about chocolate, but anything related to questions, go into Q&A, please. So we're starting out with the abstract at the long ago advice of Buck Woody, which is let's make sure what we're talking about and why we're here. And this conference is about the internals, right, of SQL Server, how things work. And statistics are fundamental. You've got sessions today about memory, which you just heard from Bob, about IO from Argenis, TempDB from Pam, and AGs from Joey. And with regard to specifically things like the resources, memory, IO, CPU, so much of that and how those are used comes back to statistics. So it's essential. And I will debunk Bob's comment in his session about having to use the debugger. I didn't get that memo, I'll be really honest. I'm not using the debugger today, but I still think that this is good, deep content. And if you're not familiar with SQL Server or are just starting out and haven't done a lot with statistics, this is definitely going to be a ton of content for you. So this is just the abstract as a reminder of what we're going to talk about today. And our roadmap is a little bit of a review, talking about viewing statistics, what happens when they go bad, and then updating them, because there's really some important things to consider around updates. It seems pretty simple, but I'd argue that it's not. So the reason that we care so much, the reason that I care so much about statistics, this was one of the first topics that I talked about when I started presenting, is because this is the information about your data in your database, right? And specifically, it's the distribution of data in a column or set of columns in a table or an indexed view. And this information is stored as a blob in system tables. And it's vital for the query optimizer because it uses statistics to estimate how many rows are going to come back in a query, right? It's basically estimating what's called cardinality. And that then determines a ton of other things, right? This then says, what index should we use? Or do we need to scan a heap? Or do we need to seek or scan a non-clustered index? And how much memory do we need, right? Bob talked in his session about resource semaphore and memory being allocated for a query, right? That comes from statistics. So these are absolutely essential because good, accurate estimates are going to help the optimizer generate a good plan, right? That's always what we're looking for, is a quote unquote good plan. So a couple notes about options related to statistics to make sure that you've seen these and you kind of know what they are in your database. The first one is auto create statistics, which is enabled by default. You'll see it's set to true here. The next is auto update statistics, which is also enabled by default. General, I recommend leaving both of those enabled. Auto create, actually, I always leave enabled. Auto update statistics, there may be scenarios, but there are really some considerations around that. And in general, I'm going to tell you that I want you to have auto update enabled. Auto update statistics asynchronously is defaulted to false. There's a lot of people that say you should enable that. That's one of those settings that I want you to understand what it does so that you can make the decision. We'll come back to that later on. And then auto create incremental statistics is specific to partitioning. So if you're not using partitioning, don't worry about that. If you are, then it's probably something that you do want to enable. So how do we get statistics in the database? And the majority in your database are created automatically without you probably even being aware of it. So every time you create an index, a filtered index, or an indexed view, and I'm specifically talking about row store for this session, the majority of the time, whenever you create one of those indexes, a statistic is created. So for example, if we created a non-clustered index on the sales orders table on the order date column, and we query sys.stats after creating that index, what we will see here is a statistic. And where I sometimes find people get confused is that the statistic for an index has the same name as an index, but those are two entirely different entities, right? A non-clustered index or a clustered index, that's a physical a representation of the data on disk. And a statistic is a blob that tells about the distribution. And for an index, they do have the same name, but they're two different entities. Now, we can also have statistics for individual columns in the database get created automatically. So if you query or you join on a column, you get a statistic. So in this example, we're querying on expected delivery date. And expected delivery date is not a leading column in any existing index on sales orders. So when I query that column for the very first time, and then I look in sys.stats, you'll see that I get a column level statistic automatically created for me by SQL Server. And I know that it's automatically created because of the naming convention. Nobody would probably ever name their statistic _WA_sys and then the numbers and letters that you see after it. So when you see that prefix, you know that it's a system created column level statistic. And not just when we query those columns, but also when we join on those columns. So if I expand this a little bit and join on the back order ID column, I also, when I check sys.stats, see that I have a statistic for that column as well. This is expected, this is normal, this is necessary for the optimizer because those statistics also provide information about the distribution of data in those particular columns. Now, as I said, you can create statistics manually. You can create them for individual columns. You can create them for across multiple columns and for filtered values in a column. This is not something I do frequently. Very rarely have I created single or multiple column statistics. I have created filtered column statistics for cases where I have a table that's really, really large and has a lot of skew. Kimberly has a great presentation that talks about skew in data and creating filtered statistics. She did a past session on that back in, I think, 2013. And it's on our website if you want more detail on that. I'm going to take a quick detour for one slide to mention Columnstore and in-memory tables. The statistics that exist for Columnstore are not the same thing that I'm going to talk about today. They have information about row groups and about the segments, but nothing like the density vector and the histogram that I'll refer to with row store. In-memory tables, which are not exactly row store either, but they do have index and column stats, although you cannot create a filtered statistic there. And there's a couple notes about that as well, but today's session is really focused around statistics we see for the row store tables. Now, how do we look at these? Because it's great that they get created and they're there and that's awesome, but I really want you to understand how to see them, because this is going to help you understand how they're getting used by your query. So sys.stats is the main system view that I use to look at those. And you can also use stats date to see when the stat was updated. DBCC show statistics is it's my favorite DBCC command. I know that's dirty, but it really is. And it has three parts to it: the header, the density vector, and the histogram, which we're going to dive into. And in later versions of SQL Server, they've added a breakdown of some of this information. So DMDB stats properties has header info, and DMDB stats histogram is the histogram. I still tend to go back to show statistics, as you'll see here when we pop into this. So let's open that up. So I'm working with a copy of Wide World Importers that I've inflated. So just to make it a little bit more fun in terms of the data that we have. And I want to look to see what we have here for the indexes on the table. And I just like to always point out when I do that, that SP Help index is built in and it's nice. But I really like Kimberly's version, which is an SP Help index that she's written, because it gives me information like the index ID. And it doesn't just have the index keys. It also has any included columns. So when I'm tuning, troubleshooting, I want to know if there's included columns in an index, and I go to this. I can also dig more into the internals with her script as well. But today we're really going to focus on this index right here, this index that's on the customer ID column on the orders table. And if I look at the statistics for this object, you can see that we've got our statistics for our clustered index here, for our non-clustered index here, and then for the column level stats that were automatically created by SQL Server. I like SP Help stats here because it also lists the column, and that's the only way, unless you do a little bit more creative T-SQL, to quickly find what column a column statistic is on. But this is deprecated, but you know, it's still there, like a lot of other things that are deprecated. Now, show statistics is what I like to use to look at the statistics for a column. So let's look at what we've got for this customer ID. And we'll start with the header, right? This is when the statistic was last updated, which is just a little bit ago. I'm on Eastern time. So 10:13, this is when stats were updated. Number of rows in the table at the time of update, number of rows that were sampled. And statistics, even though they represent the data that's in the column, they are not constantly updated like an index is, right? The index always represents what's in the table. The statistic is not. It only represents what the data look like at the time of the update. I also have, if I scroll over here to the right, some information about filter, if it's a filtered index, and then a persisted sample percent if I'm using that option. The density vector is here in the middle. This helps me understand the uniqueness of this column. And then down here we have the histogram. And this is what I want folks to understand how to read. So we have customer ID. And this range high key is basically a different customer ID. Customer ID 1, 4, 10, 15, etc. And the range rows, I'm going to hold for 1 second and hop over to the EQ rows or equal rows, right? So for a customer ID of 1, we have 5,346. For customer ID of 4, we have 5,457. Now there's several hundred customer IDs in this table, but in my histogram, I only have 200 steps max. I only have 188 in this one, which means that very often, not every row, not every customer ID is going to be represented in my histogram, which is why we have a range rows column. The range rows says that for every value between the previous entry and the current one, that's the number of rows that exist. So between 1 and 4, we have 10,891 rows. So for 2 and 3, basically we have 10,891 rows. And then distinct range rows is the number of distinct values in that range. So 2. And then the average is the math, right? 10,891 divided by 2. It's really easy when you break it down like that. And this is what the optimizer uses. So we have a couple alternatives. Again, I had mentioned this, DMDB stats properties and histogram for looking at this information. And I do like the stats properties because it gives me the rows and the rows sampled, as well as the modification counter, which we will also come back to. And again, here is the histogram. So the exact same information we saw before, right? For the customer ID value of 4, 5, 4, 5, 7 rows that equal that. Now let's enable the execution plan with our runtime statistics. And we're gonna take a look back in this histogram specifically for customer ID 42. So let's scroll down here, and this is the row for customer ID 42. And it says there are 5,295 rows for a value of 42. So if we run our query and take a look at what SQL Server says, right? It says right here, this is the number of estimated rows, 5,295. That matches what was read or what was returned. So this estimate is accurate, right? And it pulled it right from the histogram. So what happens if we pick a value that's not in our histogram? So let's take a look back here, right? We had used 42 before, right? That matched. Let's take for a value 52. So 52 is not in our list. It falls between the 50 and 55. So we have 16,212 values or rows between 50 and 55, three different distinct values. So the average there is 5,404. So what we should see here when we execute this and we look at our plan is we see that the estimate is 5,404. Okay, so even if the exact value isn't represented in the histogram, it still can obtain an estimate for that. Now, what happens if I use a local variable? So I'm going to declare my customer ID, set that equal to 42, and run that here. And we get a little bit different here, right? Instead, when we look at this, right, the estimated number of rows is 5,845, not exactly what we saw before. Now, why is that? It's because it doesn't know at optimization time what this is. So it uses the density instead. Remember, I had mentioned that and I said, I'll come back to it. So let's go back to that right now. This is the density vector. And this is basically how unique is this column. And the estimate that it gets in that plan is basically taking this density value, so 0.00158, and let's just make sure that's what I have in my equation, yes, times the number of rows in the table. So if we run that here, we get a 5845, which matches, right, what we saw in this plan, 5485. I'm horrible sometimes with remembering numbers, but there we go, right? So in some cases, it can actually, right, get the value exactly from the histogram, but sometimes it cannot, and so it has to use the density vector. It's important to understand the difference because in some cases it can be exceptionally wrong. Let me hop back to my slides here for a quick second. Let me minimize this. And I want to give you a visual for the histogram. So there's a question, you can have 201 steps. Yes, so 200 steps, one additional step in a histogram if you have a null. My customer ID doesn't allow a null, so we don't have that in mind. But here, if we took a histogram and we took that table basically and we flipped it on its side, this is what you would see, right? This is our distribution of data. And again, not every customer ID value is represented here because we have a limit of the number of steps that we can have. Now, sometimes when you're trying to understand the distribution of data, you probably do something like a count, right? Select the customer ID, the count from sales order, group by that customer ID, and then order by count descending. So when we look, I'm going to go back for a sec here. When we look here, right, I can see that there's definitely some skew in my data. I even see it a little bit better here, right, as that kind of tapers off. I like this visual representation to remind myself of how that data looks. Now I'm going to hop back here. What happens if I use a local variable again, but rather than an equality, I use a less than? So let's see what we get here in terms of our estimate. Notice that rather than seeking our non-clustered index, this switches to a clustered index scan. And the estimated number of rows that we get here is a lot larger. It's over 1 million. Not the same as what it returned, right, our estimate's way different. And that's because in this case, when we're doing greater than, less than, our estimate is 30%. So if we do the math here, 1.1 million, right, which matches what we saw in the plan. So there are some cases where it can't do an actual peek into the histogram and do the math. So it has to come up with another way to estimate that data. Now we're going to take our query and we're going to push that into a stored procedure, because I'm going to guess a lot of folks have a stored procedure and have stored procedures in their system. And we're going to run this for the first time with a customer ID of 42. And 42 is a fairly unique. You understand that here that we get that same plan shape we saw before with a seek and a key lookup. And if I hover over this, we go back to the same value that we had before with that 5,295 rows. That's what it estimates. Now this plan, because it's a stored procedure, this gets cached. And so the next time I run this for a value of 823, we have that same plan in cache, but now you'll notice that the estimate, which was based on that initial value of 42, it doesn't really work here, because now we're getting 22,000 rows returned. And maybe this isn't the best plan for that particular value, but this is what happens when we have a procedure and it gets cached. So this can sometimes be problematic if you have a large amount of skew in your data. Now, if we do something a little bit interesting, like not pass in the customer ID, but pass in something else, and then declare the customer ID and set the customer ID and use it in a query, we haven't given the optimizer doesn't have the information that it needs at compilation to know what that customer ID is. And so its estimate ends up going back to the density vector. So I run this for a given order ID, and when we look at this index seek here, right, it goes back to the density vector value that we saw before, 5,845, even though just 177 rows are returned. That works out okay for that particular order ID, but for this one, it's a little bit different, because here we get, again, our 22,000 rows returned, which may not be ideal, because that's a lot of data, and that clustered index scan might be more efficient in that scenario. Now, what happens if, rather than just doing some inequalities here, we do a little bit of a range of data? And we're going to expand that query that we started with, and we're going to also join over to order lines. And we're looking at a range of order dates. And I'm going to run both of these queries together and look at the plans for those side by side. So here you can see that we end up with kind of similar plans, but not. We both start with a clustered index scan. And when we look here for a 1 month date range, right, we're estimating about 1,900 rows or so. And that's what we get in the end. Down here with this clustered index scan for a larger date range, we're up to 98,000 rows. But we get some differences here in that with the larger set of data at the bottom, this feeds into a hash match. And what we see on the order line side is an index scan, because the estimate against order lines also depends on how many rows it thinks is coming out of the orders table. And in the case where we have a smaller amount of data coming out of the orders table, it doesn't scan and index against order lines, it does an index seek. So estimates don't just affect that one table, they're going to propagate, right, and affect the entire set of tables and the plan that gets generated when you're joining tables together. And in the worst case scenario, what can happen is that a poor estimate can propagate all the way across the plan and choose non-optimal parameters, or excuse me, non-optimal operators. And just as a reminder, we do have statistics on order date, even though that's not in an index. We do have a column index, excuse me, a column statistic that gives us information about the date. So the optimizer can use that. Now, we're not going to be very nice here. We're going to mess with the optimizer a little bit, and we're going to look at the number of rows and the number of pages in this table. So in this clustered index, we've got 3.6 million rows, and we've got about 34,000 pages. So what happens if we mess with the optimizer? And don't try this at home. This really should say, like, don't try this in production. Don't do this in any important database at all, because you can't actually undo it as completely without updating stats and things like that. So we're going to say update statistics, and we're going to specify a row count of 1 million, which is less than a third of what's actually in the table. And we're going to drop the page count to 9,000. So I tried to kind of do a realistic assessment of, if I drop this to 1 million rows, what's the appropriate page count? So it's about 9,000. So we're going to totally lie to the optimizer. And we're going to rerun both of these queries. Exact same input values, right? One is for 1 month, January. The second is for June. And now this is completely, these plans are similar to what we saw before, but our estimates are very different, right? In terms of how many rows it thinks it's going to return, right? This is 522. We still have a similar plan. And for here, our estimate is 26,000, which is way less than it was before. Now, if you look at the shape of these plans, they're the same shape that we had before for both of them. But what we've done is we've influenced not just the number of rows that it thinks it's going to return, but also how much memory it needs for the query. Again, one of the things that Bob talked about in his session was resource semaphore, right? And the fact that that grants memory to queries based on its estimates. And so here, we didn't have this before, but now you can see that for our sort, we have a warning. Because what has happened is that we didn't have enough memory allocated because the estimate was wrong, and this has spilled to disk. The irony of this session today is that I've spent the past 2 weeks working with a customer on issues related to statistics, and it first manifested as a bunch of queries with sorts and hashes spilling to disk that didn't previously. So the estimates were off in their environment because stats hadn't been updated. And they have lots and lots of large tables, tables that are 100 million rows and higher, that didn't have good estimates and thus were spilling out to TempDB. So particularly with operators like hash and sort, which rely on those estimates to determine how much memory, these statistics really become critical. And if we open up the properties here for our plan and we go onto our select, you can see here the memory grant initially is 2528. This is in KB. And for our next query that it requested a lot more, and it still wasn't enough, right? Because we totally lied to the the optimizer about what it needed. Now, this statement kind of cleans up statistics. And I say kind of because if we make that change and then come back and look at what we have in sys partitions, you'll see that the row count still sits here at 1 million. My page count fixed right up, but I would have to do an update statistics to get that to be correct. I'm just going to leave it there for demo's sake because I like showing how poorly this can behave. I'm going to make a change here where I'm going to turn row mode memory grant feedback off. This is a new feature in 2019. And if you were listening to Bob's session, he made a comment that with this in 2019, he hasn't seen the same type of memory grant problems. So I'm not saying that you should disable it in any way, shape, or form. But for this example, we're going to take that query and we're going to put it into a stored procedure and run it without memory grant feedback. And I'm going to run it the first time. This is rude. I'm going to run it the first time with a small amount of data estimated to get this plan into cache. So this looks okay. We've got this sort, and we have the nested loops. So this is the only place where it's really going to request a significant amount of memory based on our estimate. And so if I run this for 6 months worth of data, we can see that this spills, right? You can see in the pop-up that we've got the warning that this has spilled to disk. So this wrote 504 pages. And as we get even higher, this spills even worse when I ask for more data, because again, the estimate is based upon that initial, those values from the initial compilation. And we are not allowing it to get any kind of feedback. And this is what's happening in 2017 and below. And you don't have an alternative until you upgrade. And what we see here with this sort is now we're not talking just about a few hundred pages. We're talking about 9,920, right? And this took significantly longer to execute than the previous iterations. So memory grant feedback is very helpful. It is not, in my opinion, a complete replacement for making sure your stats are updated. So if I rerun all 3 of these again, after updating, changing the database option, to turn memory grant feedback back on, when I look at my output here, right, this is the plan that gets cached, I still do get a warning here. And if we look at the properties for the plan, one of the things you'll note is that if we look here at the memory grant info, this is kind of helpful, right? We can see the memory that gets estimated here, and before this wouldn't have changed. But in terms of the memory grant info, it doesn't change after this first execution, but on our second execution, this should pop up. Now, I probably needed to do a recompile in here. So let me just drop this and recreate this. After changing that option, I would have expected the plan cache to clear. So we're going to make sure that this is enabled. It's possible I didn't run that. And then run all of these again, because we should see that memory grant feedback kick in. Again, that can help in a scenario where we have wildly varying data and it's difficult to make your code handle that. Or in a case where statistics are just woefully out of date, or where you've got an issue with how the data is moving through the plan, and you want to kind of let SQL Server help you out and address that. So let's see, 2464 here. Let's come back in here. If it's still in 264, I'm gonna just call this demo a little bit of a wash and not worry about it for the moment. But that should be in play here in 2019. I'm not sure why it's not running for me perfectly. But I'm gonna pause, take a drink of my water, see if I got any questions.
We do have a few questions. So let's see, why is auto create statistics still an option to turn off? As in, when would you benefit from having no stats for columns in tables?
Auto update or auto create?
He says auto create stats.
So you're saying, why haven't they removed the option? Because there's probably someone out there who doesn't have it enabled, and it would be a problem if they did. Like, do I know that person or that company? No. Do I think it should be off? No.
Okay. Regarding statistics, is there any way to manually update stats asynchronously?
Is there any way to manually update stats asynchronously? I don't quite understand that question, because when you manually update statistics, you decide when they're going to update, right? So you can decide, I want to update them now or later. The async option means that when the auto update kicks in, rather than updating right when the query that uses that statistic executes and basically holding up that execution, it does that in the background. So if you can maybe rephrase that so I can understand a little bit better.
Okay, so Ruben, if you're still listening, that was your question. If you want to offer clarity, we'll try to get to it. How is the density vector value calculated?
It's based upon the uniqueness of the statistics. So, or the values in the column, right? So how many unique values do I have in this column based upon the number of rows in it that determines that density.
And is the 30% figure for range queries hard-coded or based on some estimate of a value's position in the total table data range?
That's hard-coded. So whether I used a value of 1 or whether I used the max value, the estimate's 30% in that particular scenario.
And a question of clarity, do you get 200 rows per partition or per statistic for the histogram?
If I'm using partitioning, I believe that's specific to partitioning. So if you turn on incremental statistics, which is that database option, then you're going to get histograms for the partition, but the kicker, then you can update statistics at the partition level, but the kicker is that partition level statistic information gets folded into the table, or excuse me, the index level statistic, and the index level statistic is what the optimizer uses. So I have a blog post, I have one or two that talk about that. It's a deficit, in my opinion, with regard to partition statistics.
Let's see, let's grab one more. Does feedback use only the previous execution? So can you get a ping pong effect where it adjusts up and down when you run against wide variations back to back?
It can, and if it is going up and down too much, it can eventually just turn itself off. So it will adjust based upon the different values that you're entering. And it can, if it's going up and down, up and down, up and down, it can decide to turn itself off.
Okay, I will let you go ahead and get back. We'll save any other questions.
Cool. I'm going to run something for my next set of demos. I'm going to hop back here to the slides. And this is really just one slide before I hop back to a demo, because I'm a very visual person, and I think that statistics are something that you really need to see. So I don't spend a ton of time in my slides. But I want to have a little prep here now for how the optimizer uses statistics. You've seen this a little bit, right, in the sense of estimating how many rows are going to come back. And we messed with this in that last demo for memory grants. So it's going to figure out, okay, how many rows do we have? And based on those rows, how much memory do I need to allocate for a hash or a sort? It's also looking at that estimate to decide how am I going to go get the data. And so you pass in your query to the optimizer, and it's going to decide, right, what object am I going to use? And by object, I mean index. Am I going to use a clustered index, a non-clustered index, an indexed view, right, or a heap? What am I going to do? And then am I going to seek or am I going to scan that in order to find the information? Again, based on how much data I think it's going to return. It's also going to influence the type of join. We're going to see this in the upcoming demo. And we looked at it a little bit in the past when sometimes we get a nested loop, sometimes we get a hash match. And then again, how much memory are we going to need? Now there's more things that it influences. This is just kind of where I'm focusing today based on time. So part of the optimizer is to estimate all this, decide what objects you're going to use, and then put that plan together and pass that along. So what happens when stats go bad? And I've purposefully made stats go bad in this demo. So before, in that first demo that we rolled through, I had everything all good and up to date. Now I do not. We're still using the same database, wide world importers B because I blew it up. And we're going to look at customer ID statistics here. And this is a little bit different than what we saw before. Before we had a full scan, right? 3.6 million rows, and we'd sampled all 3.6 million. Here we've got a default scan. And a lot of times I'll tell you the default scan is fine, but there are cases where it's not, depending on your distribution of data. So we have in this histogram, we end up with actually 200 steps rather than the 188 that we had before. But we're still working with column ID, with customer ID. And we're going to turn on statistics.io and time. And we're going to run this query that we ran before, but now we're going to join to order line. So before we just queried orders for customer ID 42, now we're going to query both orders and order lines. So we get that little bit bigger plan. Let's make sure that I'm viewing the plan with my runtime stats in there. And here we go. So here's my index seek, and our estimate is just a tiny bit different because we are using a default sample, so it doesn't quite have the numbers that we had with the full scan. So here it's estimating 5,488. We actually come back with 5,295. So that's not too bad, right? That estimate isn't too out of whack. And if we look at what we have for IO, against that orders table, we get about 16,000 reads, and against order lines, we get 49,000. Now let's try with a different customer ID. Excuse me, we're gonna go with 823. Also an important error in SQL Server. Now, we get the same shape, right? The same plan shape. We've got an index seek with the key lookup. And if we look here, what it estimated, about 5,500 rows, but now we get 22,000 rows returned. So estimate and our actuals are off, right, by a factor of 4. And it doesn't look so bad when we look at the plan, right? It's hard to tell sometimes just by looking at a plan, oh, this isn't great. But when we look here, now we went up to 279,000 reads and 67,000 reads against orders. Let's see what happens with 422. And there's a method to this madness. And this is taking a little bit longer, right? Now we're up to 3 seconds to execute. And same plan shape that we had before, and now our numbers are way off, right? This estimated 2,700 rows, and it actually returned 119,000. And if we look at our IOs, we went up to 1.1 million against order lines and 366,000. So this is just way out of whack. And you look at this demo and you're like, well, that's a lot of reads. I'm thinking, you know what? This is a lot of reads, particularly if it's a query that runs a lot. And 3 seconds in a demo doesn't feel that long. But to users who are used to queries returning in 100 or 200 milliseconds, 100 or 200 milliseconds, when you throw a 3-second query at them, they know. Like, I've talked to those users and they know when things are slow. They can't tell you why, right? But they know that it is not what it is supposed to be. So I'm going to take note of this data, and let's just look at stats really quick. So if we look for 422 in our histogram, right, it has an estimate of 2,700 rows, but obviously that's not correct because we had over, we had a few thousand coming out of that. And now we're really going to mess with the data. We're going to update a whole bunch of rows in orders to have the customer ID of 422. So this is kind of rude because, again, we're kind of messing with the optimizer here, but I want you to understand what can happen if these are out of date. And I'm going to turn on the live query stats because this is one of the things that I run into in troubleshooting. I'm going to run this query. It's going to have the same estimate as before. It's going to have the same plan as before. But when you watch the live execution, right, you can start to see, right, that over here on the right, this index seek was supposed to be 2,700 rows, and it's way above that at this point. And that takes about 9 seconds to complete. And in a production environment with even more data, something like this takes even longer because this estimate with the seek and the key lookup into a nested loop is incredibly inefficient for this many rows, right? This should be a merge or a hash going on. And this is very often where I see issues with statistics bubble up as problems. A lot of times that we get plans that have nested loops when we really should be doing hashes or merges, and these just take a long time. And these don't drive IO like our other queries, and they just kind of trickle along. They just take a long time to execute. Now, I made that whole thing possible by turning off auto update. So I totally messed with that setting. I told you to leave it on, and then I went and turned it off. Now I'm going to turn it back on. And back in the context of our database, and let's make sure that we have our plan with our runtime stats. We do. At this point, we're going to look at what happens when we query 422. And remember, before we had an estimate of like 2,700 rows for that. And now, if we take a look after this finishes, what do we get? We have a different plan, right? Now we have a clustered index scan, and it feeds into a hash match, as I said, because now we have much better estimates, right? It thinks 683,000. Actual was 688,000. So when I turned auto update stats back on, and then I ran that query again, it said, hey, I'm going to update statistics because they are woefully out of date. And it did. It still updated them with the default sample, but this is 1134, right? So this just happened. Let me hop back to my slides for one sec. Automatic updates, I think for the most part, are a good thing in SQL Server, right? You need to have the auto update statistics option enabled. And the auto update kicks in when the number of modifications to the column for the statistics exceeds a particular threshold. And there's two thresholds that you've got to be aware of. There's the old threshold, which was 20% of the rows plus 500 changed, right? When that threshold was hit, then it would go ahead and update. It would mark the statistics as invalid. And the next time you ran a query that used those statistics, it would update them. The new threshold is the square root of 1,000 times the number of rows in the table. And this new threshold is way smaller than the old one. Because if you think about tables with 100 million rows or 10 million rows, 20% plus 500 was a long time to get to. And so for some tables that are really volatile, that are larger, customers needed this new threshold, right? They needed them to update more quickly. So this is the default behavior in 2016 and higher if you have compatibility mode 130 or higher if you're on a later version. You can enable this on earlier versions using trace flag 2371. So that goes all the way back to 2008 R2 SP1. So I just wanted to point out that update because now we're going to talk about these automatic updates with SQL Server and what happens with our plans. So particularly, I want to talk about the plans as they relate to our procedures. So here's stored procedure. Looks just like our query, right? We're just passing in customer ID. So we're going to run this first with a customer ID of 192, and we're going to run it 10 times. And it's going to go through, and it's going to give us the plan for every single one. And this plan is an index seek with a key loop. So this is a more unique value. You've seen, right, that we're shifting between two plans because this is a parameter sensitive query. So this time around, our estimate was 5,800. It was just a little bit under that, but it was pretty accurate. And we ran it 10 times. So now if we look in the plan cache, we should see in the plan cache, right, an execution count of 10. And this plan was created at 1137. And we also have our plan over here along with our text. That's great. Now let's understand a little bit more about this modification and this threshold and when we're going to have an update. So if we look at sales order and we specifically look at our non-clustered index and the statistic for that, right, we can see that this was last updated 1134, right? These other ones haven't been. But here at 1134 was a default sample, right? Was not a full scan. And under the old threshold, we would have to modify 737,000 rows before an auto update would kick in. The new threshold, as I said, significantly lower. This is 60,000. So let's see what happens when that gets kicked in. So we're going to go ahead and we're going to update about 60 and change. I think it is 70 and change. There we go. And if we look back here at that same output that we looked at before, right, here we can see, okay, we've had modifications of customer ID. That exceeds our 60,000 threshold. Now, at this point, right, the statistic has been marked as invalidated, but it hasn't been updated yet. But when I run this stored procedure, it will note that and it will go ahead and update them. And so if I look here in the plan, everything kind of looks the same here, right? This is the same shape. Our estimate compared to our actual is pretty good. It's spot on. Did statistics really update? Yes, 1139. We have a little bit later time. Still with the default sample. And if I double check back against sys.stats, my row modification counter was reset, right? So when it updates statistics, it resets that row modification counter. And if I check within the plan cache, my execution count is now just going to be 1, right? Plan generation num 2, right? Creation time 11:39. So updating stats causes my plans to recompile. Now, sometimes this is what causes an issue, because maybe you have that good plan in cache, which works really well for most of your data, and then your stats update and the plan recompiles, and the next execution is with a not so good value. And tracking that, finding that, can be a little bit tricky, which is where extended events comes in. We can track auto updates to recompiles to understand if that's what's causing a shift in our plan. Now, query store is also extremely helpful here in looking at plan history, but this helps us pinpoint that the plan changed because of a recompile. So for the auto stats event, we're going to filter on our database ID. And for our recompile event, we're filtering on specifically on statistics update. So we'll go ahead and start that up. And then we're going to start the event session. And I'm going to, within Management Studio, we're going to watch live data. And I'm going to try to view this side by side. This worked when I had a larger resolution. Hopefully it still works good now. So we're going to go ahead and update some data, because I need to modify data in order to have the auto update kick in, right? So we'll go ahead and make this change. And at this point, all we've done is change the data. The stats are invalidated. And if you look here, right, you'll see that this just says loading stats without updating, loading stats without updating. So the auto stats event fires a fair bit. So you definitely want to filter if you use that. Now, if we look to see how much data has changed at this point for this particular statistic, we can see that we've got about 100,000 modifications. That exceeds that threshold. So now if I rerun my stored procedure, here's my execution plan, right? A little bit different. And I'm going to pause over here in this viewer and take a look and go back up, because we saw it, right? Here is the recompile event right here. And the recompile has the object name, right? My store procedure name. My recompile reason is that the statistics changed. I have the statement as well here. Where did this go? There it is. And I have auto stats tied to that. So here is my other for an auto stats entry, which is that it was actually a statistics update, and it tells me what statistic updated. So sometimes when you've got some volatility in your tables, and you've got plans that seem to be shifting a lot, this type of event session can help you narrow down and confirm that statistics is the problem. So we'll go ahead and stop our event session. And I want to roll through one final scenario here, a potentially problematic one. We're going to recompile that stored procedure. We're going to force that to happen. And we're going to run it with customer ID 414. And this plan is that more unique value plan, right? Which has our index seek and the key lookup that feed into the nested loop. So this works really well for our more unique values. And if you think back to the distribution of data in this column, it's pretty flat for the most part. This plan works for a lot of the data. Now we're going to update data one more time, but this time we're not going to update the orders table. We're going to update order lines, and we're going to mess with order ID. And now in a production environment, we obviously don't go updating data willy-nilly, but data gets added, right? And data gets modified. And this is a query that joins to two tables. So the statistics for multiple tables are involved in a plan. And if we look at our non-clustered index here, we can see that we have a decent number of modifications across the board. We've just exceeded that threshold of 8,600 here for this non-clustered index, which is what we were using in that plan. Let's just double check, right? Let's confirm, right? This sales order lines order ID non-clustered index, that's what we just modified a bunch of data in. And if we look at this plan in cache for our procedure, right, it reads against that, this is the orders table, here it is, against that non-clustered index. So we haven't touched orders, we've only messed with order lines. Now, what happens when we run this with a different input parameter after modifying that data? If we look at our plan shifted. And I want to use Query Store to show you this just in a little bit better detail because it's the fastest way for me to do it, to be quite frank. Let's bring this back to center. Right, over here, if I switch this into my grid view, and this is my query in question, right, you can see that I have these two plans. And if I open them up and compare them side by side, you can very easily see the difference here. Now, when we look at this data, right, the duration total isn't really what I'm interested in. I'm more interested in average duration. And when I take a query from 200 milliseconds to 800 milliseconds, right, people are going to notice. In the demo, it's not as easy to see, but in a production environment, when this happens, right, you suddenly get notified of, hey, what happened here, right? All the time I'm trying to run this, now all of a sudden, all these executions are slower. And if you don't know that that plan changed, you're like, what the heck happened? What went on? And so, you know, you can look in cache and you can say, okay, we've got, you know, this plan, this doesn't look like a good plan. I'm not 100% sure why we got this plan. Maybe we have an issue with statistics, right? This is an initial troubleshooting response so many times, right? And so you look at the orders table because that's what drives this query. And so people tend to go there first and you look and you're like, oh, man, we don't have a full scan. I wonder if we need to have a full scan. And so you fix it. You fix it by updating with a full scan. And here's the thing. A lot of times that seems to quote unquote work because you just caused a recompile. However, there are cases where updating statistics doesn't recompile. And I'm going to run this again with this input parameter. And you'll see that we have the same plan against that clustered index. So we updated stats, but the plan did not get invalidated, right? I can see that they're updated. I updated them with a full scan, and that's exactly what happened. But if we look in the plan cache, this has eight executions, right? It just executed and it didn't recompile. And this is one of the things that is a take-home message right here. In SQL Server 2020 and higher, when stats are updated, if no data has changed, we didn't have the modification counter change, then plans won't invalidate. It'll update stats like it just did, but my plans, they weren't invalidated because stats hadn't changed, and so the optimizer saw no reason to do that. Now, before 2012, if you updated stats and you had auto update stats enabled, plans were invalidated, regardless of whether data had changed or not. But there's a fun little caveat here, and I mention this because I know that some people still have below 2012, right? If you updated stats and you had auto update disabled, plans were not invalidated. So this was kind of a tricky scenario. And I mention this specifically not for, no offense, those of you who are on older versions, but for those of you that are on 2012 and higher, if updating stats is your first response, that may appear to fix the problem, but it really hasn't solved it. In some cases, it's not going to do anything, right, if data hasn't changed. So I think that's a really important thing to be aware of. So you need to manage stats. They're going to update automatically if auto update's enabled. And this can be asynchronous and probably isn't necessarily a bad option for you to have enabled. Just understand that when you have asynchronous update enabled, when it encounters a statistic that's been invalidated as part of a query plan, if async is enabled, it's going to go ahead and run that query with whatever plan was in cache, and it will update stats in the background. If you have that disabled, which is the default, it updates stats right away. If that's a problem, if updating stats right away means that queries are being held up, in 2019, you'll see a new wait type on that, wait on sync stats refresh. So this is something to look for if you think that auto updates are occurring a lot in your environment and it's causing problems. Now, I put the threshold comparison in here because I think this is just an interesting thing to note, right? Notice how much lower that threshold is in the new scenario compared to the older one. And for cases like a table that's 1 billion rows, it only takes 1 million modifications. And one of the environments that I've been looking at lately that has a couple billion row tables, one is like 2.5 billion, they have 200, 300, 400,000 modifications a day, which means if I'm not managing statistics in some way, they could update in the middle of the day. Now, that could potentially be a drain on resources, and I may want to manage that, which is why auto update stats I recommend being enabled, but you want to have something in place to manually manage stats. Whether you have a custom script that you've set up, whether you use OLA script to manage that, you want to have something in place. And the question that I always get is, what should that be? And there's a lot of other things, a lot of other considerations before I give you that kind of an answer. There are some options that are really useful. No recompute and persist sample percent. No recompute, when you update a statistic with that option, means that if my stat gets out of date, if my modifications exceed the threshold, don't automatically update it, even if auto update is enabled. So for some customer environments where they have really, 400, 500 million row tables, billion row tables, I'll put that on for them. Because I don't want those to go off in the middle of the day. Persist sample percent I use for tables that have a lot of skew and I want to have a full scan for. So I'll do a persist sample percent of a full scan for tables for indexes that are volatile, so that when it updates subsequently, it doesn't go back to a default sample. It always has the sample percent that I've specified, which is typically a full scan. That was introduced in 2016 SP1 CU4 and 2017 CU1, and obviously it's there in 2019 as well. So when your estimates in plans are off, you can have some issues as we've seen today, right? And some typical reasons, right? I don't have time to cover them all, unfortunately. Common one is stats haven't been updated. Or perhaps the sample rate is too low with the default. Or even if it is with a full scan, there's a really uneven distribution of data and that doesn't get captured in 200 steps. Ascending keys can be an issue. That's a lot better in the current releases. Table variables don't have the same kind of estimates that you get for temp tables. Local variables and modifying things in flight can absolutely confuse the optimizer. Linked servers, partition tables, as I briefly mentioned, and then again, in-memory OLTP. So what you're looking for is, do my estimates and my actuals kind of line up? And if they don't, then you have to start to dig in to understand why. So we rolled through reviewing stats, how to view them, what happens when they go wrong, and then updating stats as well. And I've got a couple blog posts to reference that the first one is mine. The second one is Kimberly, which goes through that problem I just talked about with stats not updating, with stats updating, but plans not recompiling. And then a couple of things related to maintenance, because I suspect that some of those are going to come up here. So I have time for questions for and I'm going to leave this up here for a minute, just as a reminder that you can download the scripts, and please make sure you provide some feedback. So what else do we have here for questions?
Okay, so we have a lot of questions about updating stats and updating stats. So I don't think I realized there's probably a market for a session on nothing but update stats. So let's kind of knock these out really quickly, and then we'll get to some of the heavier ones. Have you ever seen problems with updating stats with sampling, i.e. 25 or 50%? You may have covered that on the last slide.
I have seen issues with that. Frankly, I feel like it's either a default or an all. I've done some testing with like 25, 50, 75. And there comes a point, it's a blog post out there, there comes a point where I think that updating with 50 or 75% isn't worth the time. You might as well just update with a full scan, because it doesn't really save you anything in terms of time and resource use. So I wouldn't say problems per se, but I don't know that it's worth that effort to try to make it that granular.
Okay. Is there a way to increase memory grants of the query without updating stats?
You can set a max and min grant percentage. It's a query option that you can add, but boy, you got to know your data and you got to know what you're doing in there, because you're coding that into the query. You can't modify that after the fact, right? Bob had talked about that, right? Once you get that memory for the query, that's what you get. You don't get any more, and you don't give it back until you're done with the query.
Okay, so I have two that I think are related, so I'm going to ask them together. Have you ever encountered a situation where auto update stats was a bad thing? And then there's another question: will auto update stats create any blocking?
So I'm going to answer just about auto update stats causing blocking. Right, when you update statistics, it takes a schema mod lock, so it can kind of block in that scenario, in that you can't make any schema changes, but it's not going to prevent inserts, updates, deletes from occurring, right? It doesn't block in the same way that a rebuild would. Now, have I ever had a scenario where I turned auto update off? You know, there was a time, and this was well over 8 years ago, when I worked at a software company, where we used to recommend that under the premise that we didn't want stats to automatically update during the day. But the thing is there are so many stats that get updated that you don't even think about, potentially, that when you turn that off, you are missing. So I would encourage you to take this query. Actually, you know what? I dropped it at the end of this one. It's at the bottom. I didn't really show this query, but I have it because I like it and I wanted you to have it. This down here, and I'm going to comment out my predicate, which run with caution in production, because this is going to return a lot of rows. But there's all of these other, right, statistics in your database for system objects. And if you do anything with temp tables, or if you have something that creates a table and drops a table, et cetera, it would help if I ran this in my database, not in master. You're going to have things that are being modified all the time. And some of these are smaller objects that need really frequent updates. So historically, in the past, yes, I had seen a case where I would have turned it off. But I will tell you right now, I don't have a good one for you.
Okay. Let's see. With the auto update statistics option, update stats with or without the full scan option. And if it updates without, how can I force the update with full scan?
So it's going to update just with the default. If you want it to do a full scan, then you want to use that persist sample percent option, right back here. So persist sample percent, when you run that, it's going to say every time that stat gets updated after that, use that same percentage. So again, for those tables with skew, I'll set the persist sample percent of 100, so it's a full scan, and whether they get updated as part of a job or automatically, it'll be with that rate.
Okay, so let's jump to a few other questions. So is the auto updates to stats behavior now tied to database compatibility level in 2016 or higher? An example, for folks who run a DB in, say, 2008 R2 compat level on a 2016 SQL server.
Yes. So here's the threshold as a reminder, right? So that new threshold, if you want to use that and you're running 2016 and you're running compat mode 100, you need to use 2371. And actually the resource, come down through here in my resources, this second post, controlling auto stat behavior in SQL Server, talks about that specifically.
Okay. There's a whole lot of questions. I'm trying to.
It's okay.
We have some time. We have like 6 minutes left. Yeah.
I know.
So what will be the estimation for combination of multiple columns not from the same index, without multi-column stats created explicitly?
So when you create a statistic, you can only create it on column or columns in the same table. So I can't create a statistic across, let's say, customer ID in the orders table and something else in the order lines table. So the estimates are going to come from the stats, and then the cardinality estimator, right, the optimizer, is what then has an algorithm to determine, okay, based on this stat and this stat, right, what's going to happen. And that ties to the CE, the cardinality estimator version, right, which changed between 2012 and 2014. In 2014, we have the new CE and a higher version. So now you have two, basically, cardinality estimators available to you, and they each have a different algorithm for how they do that. There's a good white paper that talks about that.
Okay. Can we insert a statistics step in histogram for a particular order ID in one of the examples that you used?
No, you can't. You can't mess with that histogram. In Oracle, you can do cool things like exporting stats and importing them back in. You can't do that with SQL Server.
Okay. Can you recommend somewhere people could get some information on, it says columnar structure tables?
Columnstore?
It says column structure tables.
If it's Columnstore, I would recommend Nico's blog. He is probably my go-to there. So hang on. I assume that columnar means Columnstore. So here. So I would recommend, if columnar means Columnstore, go here.
Okay. So for your manual process of managing statistics as part of your maintenance, how do you recommend choosing what stats to maintain? Simply off of how long since the last update? Do you have a favorite way of choosing what stats to update when?
It's a process. I'm going to tell you that. There is no quick and dirty answer. I go a lot based on this information right here. So here's my general rule of thumb. If you have a maintenance window where you can get all of your stats updated every weekend, do it. Even with a full scan, right? Having accurate statistics doesn't hurt the optimizer. The challenge with stats is the resources that they consume and whether or not you need a full scan. So my blanket advice is, if you can update them every night. I have some customers that are just 8 to 5, right? And their database isn't large enough that it needs multiple maintenance windows or whatever. If you can do them all, do them all. When you start to exceed that, then you have to start getting a little bit smarter. And this is the tool that I use to do that. So very often where I start is I start by understanding what are my objects, which are most volatile. And I also look at size. So I mentioned that I've been working with a customer for a couple weeks, and I looked at stats two ways. One was I looked based on the size of the tables, and I went by row counts. You could also do pages. And the other was I looked at modifications. So for tables, I said, where's a natural division of tables? And in their environment, they had a couple tables that were billion rows, a few 100 million row tables, and then everything else was like 30 million or less, right? 30 million or less, I can update those stats in a reasonable time frame. I can update those stats with a full scan every weekend in a reasonable time frame. My bigger tables, I have to know how long that takes and do I need a full scan or not. Now with the default sample, those can update in less than an hour, depending on how many stats are there. But with a full scan, it takes maybe 24 hours for a 2 billion row table to update, depending on the hardware, by the way, right? There's a lot of assumptions here. So I start with table size, and I also start with volatility. And table size, I can just do a point and click at any point, and I get an idea of what my tables look like in the database. You probably already know what your behemoths are, right? You probably know what your history and your log tables are that just keep getting bigger and bigger, and you can't stand managing because they're not partitioned. I get it, right? Those I'm going to separate out. My modifications, that's a different beast, right? The tables that are volatile, right, that are not just critical, but there's a ton of churn, inserts, updates, deletes. Those tables, sometimes I'm updating them throughout the day, right? So I might have a job that runs every hour, every 4 hours, that updates stats for those tables, and depending on how large they are, I might also update those with the full scan, right? Do they have skew? So those are the two places that I start, but it's really hard to just give you a do this and do this, because the factors that contribute are size, modifications, and then what do you need in terms of the sample? And I use OlaScript, by the way, as an aside. There's lots of options out there. What I like about OlaScript is that I can also manage fragmentation at the same time, but I don't have to. You can use OlaScript to just update stats. I can use OlaScript to update based upon a percentage of change, which I have a blog post that talks about that as well. I'll grab that in a second. And Ola stuff logs to the command log table in the master database, which means I have a history of what was done rather than anything ad hoc or in something that I've written. So I tend to defer to his stuff because it works and I like it.
Okay, so we're at time, but one last question.
Sure.
Is updating with a full scan different than sample 100% in a modern version as it was in the old SQL versions? And this is related to fixing corrupt statistics.
Full scan on 100% should be exactly the same thing. I don't remember when they were not. That's an interesting point, but those should be exactly the same.
So I have had a couple of questions asking where can they get your slide deck and if they're going to get the queries. And the answer is yes. You said you would make those available.
Yep. So I've already sent them to Anthony, okay. Mark, and Andrew. They were going to post them for me. And
all those links are in the chat right now.
Okay, all those links in the chat. And then just as a reminder, if you have a follow-up question related to that, feel free to send me an email. And I'm going to throw up here another blog post that I have. This is updating stats with OlaScript. So I've already said this, but I talk about a couple different things of how to use his script to update statistics as well in terms of the threshold. So take a look at that.
So I did copy and paste all of the unanswered questions into an email to you. So you'll have a point of reference if somebody follows up with you later. And their names are there if they're logged in with their name.
Awesome.
So that should help you.
Awesome. Well, thank you. Thank you, Ree, for moderating. I so appreciate it.
I love doing this.
Thanks to all of you who have attended and listened today. I hope that there was some info that was of value there and that you learned something new. And again, if you've got questions, just let me know.